Okay, so let's look at 25a from chapter 5. Uh, One thing to note is this one's definitely not an identity problem. Sine 2x rarely equals sine of x. So don't assume that just because I give you an equation that it's an identity. In this case, it says solve for the values of x. And in this case, we're only going to solve for the ones between 0 and 2 pi here. Um, what I'm going to do though is I'm going to solve for a general solution first, just so you get in the habit of doing that. Because for some of these problems, that's going to be way easier doing it that way too. Um, so anyway, for part A, I can't really combine sine 2x and a sine x in any way unless I rewrite sine 2x. Well, actually, let's do this first. Let's get it all on one side. And so it's going to be sine 2x minus sine x equals 0. Okay. So sine 2x is the same thing as sine, or 2 sine x cosine x from our double angle formula. And then I'm going to subtract out the other sine x equals 0. Now this thing you can factor. And when I factor it, I'm going to get, let's see, I can factor out the sine x. And I'm going to get 2 cos x minus 1 equals 0. So in this, now I've got two things that multiplied together equals 0. So either sine x is 0 or 2 cos x minus 1 is 0, or they're both 0. So I can solve each of these. If I solve this one, sine x is 0 when I'm at, let's see, 0 radians or pi radians. And I want the general solution, so what I'm going to do is add 2 pi k to both of these. By the way, for all these things, I'm just going to write over here, k is any integer. Right? So I'm just going to put that there so I don't forget. Okay, so that's x in the sine case. In this case over here, I'm going to get cos x equals 1/2. And that's going to happen when x is, let's see, 1/2 is going to be right here. And that'll happen when I get 60 or negative 60 pi over 3 or negative pi over 3 radians. Okay, so now I've got these two values here. Or actually, I guess I've got these four, really. By the way, this one, if you wanted to, you could condense it into just, whoops, sorry. You could condense it into just pi k. That would work too, but I'm just going to leave it as 2. So anyway, we need all of the answers in the interval from 0 to 2 pi, where 0 is included, but 2 pi isn't. So, well, if k equals 0 over in the first set, I get the answer pi. I also get 0, but, oh no, actually that one does count. If k is 1, then I get 2 pi and 3 pi, which is already outside of this range here, so I'm not going to worry about those. So this one ends up with 0 and pi as my answers. And over here, I get pi over 3. I've got a negative pi over 3. If I plug in k equals 1, let's see, I get 6 pi, 7 pi over 3. I get 6 pi, 5 pi over 3. So, you know, you can quickly see that's already out of my range. So is this one. These are the only ones that I'm going to get in that 0 to 2 pi range. So if I list off my answers in this range down here, my answers are going to be 0. I'll put them in order, although I don't mind if you don't. Pi over 3, pi, 5 pi over 3. So there are all those solutions right there. Part B is a little bit trickier because it's a sine 2x and it's a tan x, and somehow we have to find a way to turn this into a problem that you can factor and then solve each part out. So the hint that I'm going to give you for this one is that it is possible to turn, let's see, let me write down the original just so I don't forget it. Sine 2x minus tan x equals 0, right? Yeah, that's right. So my hint here is that you can use different identities and manipulations, and you ought to be able to get it to this point here, where you get sine x parentheses 2 cos squared x minus 1 also equals 0. And then from there, you can work out the rest of the problem. You might recognize this as a certain trig identity as well. If you don't, it's still solvable. You could get cos squared x equals 1/2, and then when you take the square root, it's going to turn into plus minus 1 over root 2, and then you solve out a couple of solutions for the positive version, and then you solve out a couple of versions for the negative one too. Okay, I hope that helps.